Good day, everyone. It's always a joy and amazing time to meet you on this learning platform. My name is Omo Oziegbe Godwin, and today we'll be considering a topic in mathematics, converting decimal numbers to base 2. Remember, math is always fun. We have fun while we learn. We'll play with numbers, we'll make it interesting, and then we'll learn at the end. Please, I would like for you to join me in this class today with your writing materials. Most especially it is mathematics, so you should come with your jotter, your pencil, and your biro. If you're ready, it's going to be awesome. I am also ready. So let's get started. Now, our objective for today, it's interesting. You should be able to convert base 10 numbers to base 2 numbers and identify base 10 numbers. What's base 10 number? How do they look like? What kind of number is base 10? We've seen base 2 and we said base 2 are numbers that have possible values of just 2. Remember, we said these values are 2 in numbers, 1s and 0. Alright, now we are talking about base 10. What are these base 10 numbers? How do they look like? How are they represented? Is it the normal number you know? It's going to be fun. So at the end of the class, I expect you to be able to convert base 10 numbers to base 2. And also, you should be able to identify base 10 numbers. Now, what are decimal? Decimal numbers, sometimes they are referred to base 10 number. So someone now woke up and just woke up to me and say, "Hey, Mr. Omo, you only told us about base 10 number. You didn't tell us about decimal number." Decimal numbers and base 10 number, they are synonymous, okay? That means they can be interchanged. You can use base 10 for decimal number. It's the same thing. So decimal numbers are numbers that are in their normal form without a point in between them, or in base 2. Okay, they are not in base 2. These are numbers in their normal form. Please note this, in their normal form without a point in between them. Alright, so moving forward, there are some examples that are here on the slides. Decimal numbers are this number you're seeing here. We have 45, we have 18, we have 12, we have 20, and numbers like that. So if you see something like 7, this is a decimal number. 9 is also a decimal number. 10, any number of this sort, we refer to them as decimal number. Remember, we said in base 2, we only have 1s and 0s. So these are numbers that are in their normal form. I like to say in their original format. Okay, so now you have known what decimal numbers are. Recap before we leave this slide. Decimal numbers are numbers that are in base 10 that are in their normal form without a point. Decimal numbers are numbers without a point. Alright? So we noted that. We are good to move to the next slide. Now, interestingly, we have to learn how we can convert decimal number to binary number. How do we convert decimal number to binary number? A number is said to be decimal when it doesn't have a point. That has been said in the previous slide. A given number can be converted from base 10 to other bases using division method. Very, very important. Division method. For our study today, we know we have division and multiplication method, but we're going to concentrate on division method. Now, if you are to convert numbers in base 10 to base 2, let's say base 2 specifically, you make use of this method, division method. Okay? Because the number we are dealing with, they don't have fractional or decimal parts, so we use division method. Division method is used to convert such number from base 10 to another base. We'll use purely division method to get our sum right. Now, to convert from base 10 to base 2, we'll divide. But what are you going to divide with? Are you going to divide with 10? Or what number do you use? Remember, binary numbers are numbers in base 2. So if you're going to divide, if you're going to change number from base 10 to base 2, because you are bringing a number. This is how I view it. You bring it from base 10 to base 2. So this guy is moving towards this guy. What we have to do is very simple. This is the new base we want it to be in. So we'll divide using 2. So we'll keep on dividing the number until there is nothing left to divide. So we'll divide the number with 2. Yep. Until there is nothing left for us to divide. Alright. Then we'll now transverse the remainder from bottom to the top, and we'll have that as our answer. Very simple. It's just like you're going to write your arrow. You start from down up. I call the bottom to the top approach. Alright, bottom to the top approach. So pay attention to it. Pay attention to what I'm saying. It's very important. If you're going to convert number from base 10 to base 2, we'll use the division method. Alright, so I think it's that time we look into some examples. But before, what have we learned so far? We have said that decimal number or base 10 number are numbers that don't have points in between them. Now, how do you convert numbers from base 10 to base 2? We make use of the division method. Good. We have example here. Alright, so we have to convert 18 in base 10 to base 2. It's already clear on the board, but I would like to do it also here. Base 10 number is 18. This is in base 10. So we should convert to base 2. 2 in 18, that will give me what? 9. Is there a remainder? You always write your remainder, okay? If people like it this way, there is no remainder. Because 2 can go in 18 perfectly without a remainder. Now, 2 again, remember we say continuously to divide. 2 in 9, that will give us what class? That is 4. But 2 times 4 is 8. So it's remaining what? 1. Beautiful. 2 can go again. 2 in 4, that is 2. Is there a remainder in this division? Nope. Remainder 0. Beautiful. Now 2 one more time. 2 in 2 is what, boys? 1. Is there a remainder? Nope. Remainder 0. Good. Now this is 1. We have to do it all through. 2 here. 2 in 1. Can it go? No. So we'll put down 0, saying it cannot go. This is your 1. We bring it here. 1. So what will be my answer? If you check what they did here, you can see the answer span down this way. We have 1, 0, 0, 1, 0. So what's our answer? Here is 1, 0, 0, 1, 0. That's what they have. Is that what we got? Let's check. 1. Now, how do you get the answer? Remember, we take down to up. You start calling the numbers from the bottom to the top. That's why I told you the bottom top approach. So 1, 0, this 0. There's another 0 here. 0, beautiful. There's 1 here. 1. And what do we have? 0. Wow, did we get it right? Yeah, we did. Easy peasy. What did we do? You continually divide with 2. It's so simple. I know you're going to get it right. I know it. So we started by 2. 2 in 18, that gave us 9. There is no remainder, so I put down 0. Then we went again 2 in 9, that's 4, remainder 1. 2 in 4, that's 2, remainder 0. 2 in 2, that's 1, remainder 0. 2 in 1, always remember at the point you get to this part, 2 in 1, always note you have to put down 0 and take the 1 the other side. Then you read your answer from bottom to the top. And that's your final answer. So as you can see, we got the same answer as it is here in the example. These are further examples that you may want to lay your hands on the same approach. But because of my slide, numbers are large, 172, you keep on dividing. If it goes there, that will give you 86. There is nothing remaining now, 0. 2 can go in 86. That'll give you what now, boys? 43, remainder 0. Yep. 2 can go in for 3. That'll give you what now? 21, remainder 1. Can 2 go in 21? Yeah, a good 10, but it's going to remain 1. So you keep on doing it that way. Don't be amazed. It's so simple. I know the light is already here, and you can see it. And You are getting it very correctly now. Alright, so you can do it. By the time you do it till the end, you get this same answer here. Okay, and that is, remember, answers, binary numbers are numbers in 1 and 0s. So when you have things like that, you know that you're talking about binary base 2. Alright, that's interesting, and I think you should be able to do it. Beautiful. Now, we have to convert the following number from base 10 to base 2. We have 15, we have 25, there is 30, there is 50, and 23. I know you, it's just like, wow, what are we going to do now? Someone is scratching his head, or she's looking at the sky. Oh, Mr. Moore, we don't know what we're doing, but is this difficult? What do you do first? Let me give you a head start to it. 15 and then 2. Wow, beautiful. Is someone already getting it? You know what to do? Beautiful. Another. Remember, when you're through, what you do, you read from down to the top. And once you do that, it means you've gotten your answer. Easy peasy. So I would like for you to lay your hands on these exercises. Have fun and play with these numbers. Remember what the things we've learned. They are very, very important in helping you understand binary conversion. So it is interesting time for us here, and we are glad we could meet you on this platform. Now, evaluation before we run out. What are base 10 numbers? I want to hear you say it. What are base 10 numbers? Okay. Okay. Nice job. Can you give 5 examples of base 10 numbers? Brilliant. Brilliant. Nice. So remember, numbers that don't have points, we refer to them as base 10 numbers. And if you're going to divide or you're going to convert base 10 number to base 2, what do we do? Quick one, boys. What do we do? Good job. We divide with 2, because 2 is the new base we are expecting. And then the answer will just come. We'll read from where? Don't forget, let the arrow point you from down to the top. Alright, let your arrow point you from down to the top. It's an interesting time talking to you and learning on this platform. My name is Mr. Omo Godwin, and from me over the side, it is bye-bye. Have fun and ensure you enjoy your maths. Till we meet again. Goodbye.